There is a particle A which is having a charge 2 into 10 to the power minus 6 coulombs, which is fixed on an horizontal table. Now let us say there is another charge plus Q of mass 80 grams that is placed at a distance r is equals to 10 centimeter from the first charge, and we have coefficient of friction as 0.2. Now let us see diagrammatically that we have a charge plus Q which is fixed over the table. Another charge Q dash that we have to calculate is kept at a distance 10 centimeter from the plus Q charge, and the coefficient of friction is 0.2. Now what happens is that when a charge Q dash is placed on the table, then it will experience a repulsive force from charge Q, and this repulsive force will be equals to K Q into Q dash divided by 0.10 whole square. Now this distance have to be in meter, so that's why 10 centimeter is equals to 0.10 meters, and so the repulsive force. Now this force have to be equated to the frictional force, because in the question it is clearly mentioned that the charge Q dash is in equilibrium position. It means that the net force acting on the charge Q dash is equals to 0. Now if the repulsive force is acting on a charge Q dash, then there has to be an equal and opposite force opposite to the direction of the repulsive force, so that the charge Q dash can be in equilibrium, and this repulsive force will be frictional force. So the F friction can be calculated by the formula mu into normal. Here mu is given to me as 0.2, and normal force is nothing but the mass of the particle into gravitational acceleration constant. So calculating the frictional force, that is 0.080 grams, 9.8 newtons. Now as the system is in equilibrium, that is the equilibrium condition, F repulsive force have to be equal to F frictional force. So on equating both of them, we get K into Q dash divided by 0.10 whole square is equals to 0.2 into 0.080 into 9.8. Now K is 9 into 10 to the power 9. Q is given to me as 2 into 10 to the power minus 6. We have to calculate Q dash divided by 0.10 whole square, that is equals to 0.2 into 0.080 into 9.8. On solving this equation, we get the value of Q dash as 8.7 into 10 to the power minus 8 coulomb. That is my answer.